Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Guwahati University of Science and Technology. Today we will take lecture number 30 of the subject of object-oriented analysis and design. And in this lecture we are going to explain modeling the component diagrams of UML in visual paradigm. Dear students, component diagram represents different parts of a software in a project. Basically, component diagrams are used to model the different units of the programming or different units of the programming projects in the software products. So here we are going to discuss the component diagram in a tool of UML called Visual Paradigm. This is the discussion agenda. It contains the topics of the component diagram. First of all, we will explain what is the component diagram. Then we will explain different steps used to create the component diagram in Visual Paradigm. And at the end, we will demonstrate the component diagram in the Visual Paradigm. Now, what is the component diagram? Component diagram shows the type of software components in the system, their interfaces and dependencies. So means that in the component diagram we have different components of the product and also we have their interfaces among different components. Also we represent dependencies in the component diagram, that one component is depending on another. That means that if one component is removed, the another component will also be affected. And interfaces shows that the communication between different components through a certain ports. Now component diagram shows the structure of the code itself, means that how we will organize the code in the software products, means that how many files will be there which have the codes of the project. It can be used to hide the specification details. Specification details means that if all the detail from the customers or the user will be hidden here. That means that all the information hiding is performed in the component diagram, which focuses on relationship between different components in the component diagram. So in the component diagram we have only focus on the different components and also relationship between different components in the component diagram. We do not provide any sort of the internal details about the project. Now, modeling the structure of the software releases shows how components integrate with the current system design. So it means that when we model a software system release, then it also shows that how different components can be integrated with each other, and this is at the design step, that multiple components are integrated with each other and how they pass information or data to each other. So that means that when the components are integrated, they are integrated through their interfaces, and also dependencies are defined in the components, that one component is essential for the another components. If one component stop working, then the another component will also stop working. So that's why there is the dependency among different components. It also specifies the files that are compiled into the executables, means that different files that will be placed on in a final system or on a target computer when a project will be installed on that particular computer. So that means that it represents the executable files or executable products when the particular project will be installed on the user environment. Now this is the example of a component diagram. You can see that this is signal.h components, and here you can see that we provide the stereotypes components. Stereotype means that there are a particular name of these components, and the file in this component is signal.h file and its version is 3.5. So it represents that this is the component, and there is another component signal.h version 4.0. This is another header file, and this file is using in fact this files. The signal.h 3.5 is used here. That means that this file is calling this file. Now this is another component which is calling another this files signal.h version 4.1, and this header file is called in interrupt.cpp and signal.h version 5.0. So means that this file is combinedly used here. Now you can see that there is another stereotypes of the parent. That means that this is the child of this component and this component is the child of this component, while this is the super parent. Now this component is in fact only using this component signal.h. Similarly, interrupt.cp file is calling irq.h file, means that this is another component and it is called here. Similarly, device.cpp is also calling interrupt.cpp file, means that this is our main program which is calling interrupt.cpp. So this is a component diagram example. This is another component diagram example, but here you can see that there is a little bit difference. That first we have a component and it is a library component, means that this will be a library file and it is db server interface dbserver.dll. This is dynamic link library and it is in fact representing the particular server's interface. And here is another application component, video workstation. So this is a video workstation components, and workstation.exe, it is a file which uses this db server interface.dll, and it is providing the interface, means that you can see there the icon that it is a component which is accessing this and it provides information to this file. But this file is calling application framework.dll file. This is another file dll which is in fact called here, and there is a supplied by Microsoft. It is just an explanation comment, means that this is used to explain or to provide information about this component. This is not a separate component, but it represents only for information purpose here. Now, how we can create the component diagram in visual paradigm? First, we will click the diagram and then click new from the toolbar. So here, this is the diagram panel, and here we will create the new buttons. Then, in the second steps, in the new diagram window, select component diagram and then click next. So here we will select the component diagram and then we will click the next. So here just select the new component diagram and then click next. You can use the search bar about the filter select. So we can also use a search bar here and select the component diagram to create the component diagram. Next, number 3, name the component diagram, then click OK. So here we will provide the name, for example, component diagram tutorial, and click OK. Then you will see the blank diagram, means that totally white surface where we will plot our component diagram, and we will name the diagram component diagram here in this tutorial. Then create or in this lecture. Then create the component and select the components. So here we will first select the components and then click and drag it down on the empty space on the diagram pane. So after dragging down, you will see this icon here. So rename this one according to your purpose here. So rename the component by double clicking the components. In this case, we will rename in component item.java. So here we will rename it item.java. Next, repeat means 4 and 5 steps for more components, means that just drag down these components from the toolbar into our window pane and just double click on it and rename it according to your project. So here it is item.java, loan.java, title.java, reservation.java, and borrow information.java. So these are multiple components. We have created here 5 different components. Now we will connect these components with each other. So when I will select a particular components, just select here this icons, and then drag drop per line here, this one which is a dotted arrow lines, and release this line on another component. Then these two components will be connected with each other through the dependency. So we can create some dependencies once the components are created. So here we are creating a dependency from the item.java to the loan.java. So for this purpose, just click item.java, then click and hold the resource buttons, resource catalogs, and drag the cursor to the loan and release the buttons, and then select the dependency types here from this list. So from this pop-up window, we will now see that the dependency from the item.java to the loan.java is established, and this is the dependency. So we will repeat all these steps until we get this diagram. So repeat step 7 for more dependency means that we will create multiple dependencies here, and following will be the component diagram at the end of all these steps. For example, item.java, loan.java, title.java, reservation.java, and borrow information.java. These will be the components diagram that we have created here. Now this is the end of the slides. Now we are going to perform the practical sessions here. For this purpose, click on the exit slides. You can see that slides are exited. Open your visual paradigm. First you need to create the new projects. For example, I am creating it from this restart. Then click here and type the name of the project according to your purpose here. So this is the visual paradigm interface. Here we have a component diagram. You can rename this diagram according to your project type. From this toolbar, we can drag drop different components required in our diagram. So first of all, I will drag drop a components here. So I can name this components. Just double click on it. Then you can type, or you can provide the name of the components. For example, I want to design the Pentium motherboard system. So I will write here Pentium motherboard and press enter. Now you can see that due to its size issue, the full text is not appearing. So you can resize this component. Now this component has been resized here. So we have created one component, and the name of component is Pentium motherboard. Now click on this resource icon and create another component, and this component will be created through the association. So just click here and enter type, and you can name this components. For example, this is the timer component. This is another component that we have created. Now again click here and click here, and again click on this particular component. So click here, click on this resource icon, and click on this new component that will be associated with this component, and press enter. By pressing enter, you will create another component. So for example, this will be the serial IO input output port, that is serial I input output port, and press enter in the keyboard. So this will be another. Again click here to create another components, and take the association of the another components. Click here and type here another component name. So this will be the digital input output space port. So this will be the digital input output port. Okay, now to add another component here, again click on this resource icon, select here and press enter, and type your proper name here. So this will be the right position encoder position. These are different hardware systems of connected with the Pentium motherboard. So write position encoder. Okay, and again click here in the resource icons and type the another component here. So left position encoder, left position encoder. Now you can see that this component is in fact appearing here. So you can adjust the components according to your position. Next, I will add another components here. So click here and take another components in the association and press enter and type here the name of this component. For example, this will be the drive motor component. Drive motor. It will be the drive motor. Means that it will have a motor to drive the hardware. Next, we will add another components here of the motherboard. So again click here, type enter and then type the name of the component. So this will be the steering motor, and you can place it according to the position. And the last one, we are adding another components here. So it will be the last component and type its name, ultrasonic sensor. It is the last component and you can place it everywhere you want. So this is the example of different components in the component diagram, and all components are associated with the main components called the Pentium motherboard. So it is a very good examples. You can change the stereotypes here. For example, if there is a software components, then you can specify different stereotypes of this particular components, but all of there are hardware components, so that's why these are generically we can call it components. So this represents a particular component in the component diagram. So dear student, this is the end of these lectures. If you have any question, you can drop an email to my ID. My ID is m.kadeem@kust.edu.pk. I will wait for your questions. You can also ask questions through the KCMS, and also if you have to study further, you can use these links to study more about the component diagrams. Thank you very much.